Hello, hello, good morning. Happy Friday, everyone. I learned that I can't minimize this game window, and OBS will not. It won't run for some reason. I don't know why that is. If it's not the main. Let's see if I do that. Yeah, it freezes. Interesting. I don't know why that would happen. I don't know if my other simulations do that too, or if it's something about GGEZ or something else. I don't know. So I've got to leave that up. All right. Epic Blarg, the boys are still memorizing. Or mesmerizing. Yes, I like them too. Which is one of the reasons I like starting them up. It's like, oh man, it's so fun to watch. I'm hoping that Asteroids will be like the next thing that can replace that. But of course, that depends if I create some kind of like AI that can play it. Then I don't need to then I can just have it sitting there and play itself every once in a while. But that's all besides the point. That's all something else. Also, so good morning, Epic Blarg. How are you doing today? I'm coming over here. I am downloading you. Save file. Need to open you up. There you are. Open up in Notepad. There we go. So, on the Discord, early this morning, at least according to me, Cypherpunk, shared out a really interesting, cool little document on bitmasks. So we're going to play around a little bit with bitmasks, sort of like try to grok and understand it, not just at like the surface level, but enough that we can implement it ourselves for the collision detection. So I don't have to use, hey, what type are you, and then check that type consistently. All good there. Looking forward to seeing some asteroids and UFOs being blown to pieces. I hope so too. We'll see how far we get in. We're gonna look through this this bitmask. I cannot say that word. Bitmask stuff. So see, it's a nice little mini blog post essentially, which was awesome. It was shared in that in the Discord, as I mentioned. So let's see. Think of integers as bitmask, so each flag is a bit and represents a layer or a collision channel. So for an U32, you can have up to 32 separate channels. Each object in the engine that can live in the world has an integer which states what layers, collision channels it lives in. Alternative interpretation, which layers channels it would react to others objects in. So let me also pull up on my left here. I want to think of, okay, so we're going with bitmask. Okay, so if we have layers, the idea of layers, then I would imagine that we have like a layer of 1, 2, like 3, like that, and they'd be stacked in this way. And I'm sort of imagining something like a Photoshop type tool where you can have like layers as you're editing that, or Illustrator, or anything else like that. So I have I guess we can just use, we have an asteroid on this layer. We have a bullet on this layer. We have a player. And then we have a UFO. We have a bullet. And I guess that would work. Because like these are, okay, so UFOs shoot bullets that are on this layer. and players shoot bullets that are on. Oh, okay. Then we can have asteroid here too. So players can shoot bullets that are on layer 2. UFOs shoot bullets that are on layer 1. And things can exist on multiple layers at the same time. I think that's what we get to later. So each object in a game engine can live in a world. When a collision detect between two objects is performed, it can bitwise and two integers together to see if they should interact. So I have not. So I did a really quick search up like what a bitwise and is. Bitwise and. I noticed that MDN is actually the one that comes up first for this search, and I think that has a pretty good explanation for here. A bitwise and is a count of how many of the ones line up. I think it is that. I think that that's what it is. So if we look here, only one of the ones line up, so expected output is 1. Now, if I move you to a 1, oh, wait, I can't do that. So what is that? That's a 1, 2, so these are in binary. So 1, 2, 4. So 4 plus 2, 6, 7. So if I make you a 7, then this should be a 2. Oh, you're a 3. Does it add it? No. Okay. So why is that? Or did I do my math wrong? Because it's 1, 2, 4. So 1 plus 2 is 3 plus 4. That is 7, right? Layer's a helpful mental model, but it kind of breaks down in 3D. That's why it's called channels in the 3D world. But yes, to grasp the basic idea, it's easy to think of them as 2D layers. A bitwise and will turn 0 if there are no common bits set to 1, which in this case means no interactions. Right, and so the question is, like, I'm doing this in JavaScript just right now, and then I'm going to move back to Rust as soon as like I understand. So let's say that I put, like, I don't think I can just do, because it sounds like there's channels on each. Well, can I do something like that? Let's say you're channel 1. So we do channel, and you are channel 2. So you're 2 here. These don't make any sense anymore. Then if I console log channel 1 and channel 2, I get 0 because you're not in the same mask. If I do 1 and 1, you're on 1. If I make you 3, so then you're still 1. And that goes to 4 again. There is a way to print out. I think I can do like a parse int. Is that right? There is a way in JavaScript to parse out the number and print it. So print number binary JavaScript. I know it's like not hard either. Dec to bin. Wait, is that an actual function? Oh, function decimal to binary return. Oh, right. It's a 2-string. So wait. Can I just do channel 1, 2 string 2? That? No, okay, it isn't like that at all. Deck, and then the 3 carrots? That? Well, it didn't crash, but it didn't like that either. So channel 1 is a 1. Well, I guess, let's make this like a 5. Oh, okay, it is working. It is working. Okay, so that's a 1 0 1 0 1. So it's not showing me like the 8 bits or so. Okay, cool. So we have this as a really quick function. It doesn't pad. Yeah, I was sort of like expecting it to pad. All right, so deck to binary, we bring in the decimal, and we're gonna return decimal 0. I don't. So it's greater than greater than greater than. Is that what it's doing? I don't think I've never done that before. That's really cool looking. String 2. Oh, we have to okay, so if I do that, then what I want to do is let's not console log u. Oh, I can't. We can do a deck to bind channel 1 and deck to bind channel 2. That. All right, so that gives us 1001, and you know what I can do? This might be better to do it in a separate line here. Okay, so we can actually compare these two here. So this has an and here. The greater than is an unsigned right shift. It's just there to avoid signed integer issues. Oh, interesting. Okay, I don't think I've ever done any. I don't think I've ever done any bit shifting before. Okay, so you're 4 because 0, 1, 2, 4. The 4s line up. Is that an appropriate interpretation of what's happening here? So the 4 side lineup. So this is channel 4 is hitting. So if I were to set you as, now the other thing here, okay, so for example, you can put the player and the UFOs in channel 0x01. So if I do something like, I want you to be in 0x01, I want you to be 0x02. Now I want to, so here's the console log that I want to also add in channel 1 here, channel 2, so we can see what it is. We can see it's 1 and 2. So these are the numbers for 1 and 2. I could just replace these with 1 and 2. They're exactly the same thing. And we see that there's not padding, so these numbers do not line up. So 1 and 0 and 1 and 0. So we get 0. Yes, exactly. The bits values that are set in both integers will be in the output. Okay. This way you can tell. Okay, interesting. The player's bullets on channels 0, 2, and the UFO's bullets on channel 0, 4. So I noticed that channel 3 is skipped, and is that because that would be a combination of two channels? So if I add in, if I put you on channel 3, yeah, because it's 1, 1, and 4 is that channel. So I have to think about this not in actual decimal channels, but in binary channels. So coming back to here, I would have to. What do I want to do for this? We can use text. So let's say we have these channels aren't actually going to be represented by this anymore. Now they're going to be represented by like what does it be? 1, 2, 3, 4, 5, 6, 7, 8. So we can have channel 1. Now it has to be unique, right? So then that's another channel. That's another separate channel. And that's a channel. So if we align these up really carefully, and I should make these bigger too. Actually, you know what I can do? I can just zoom in. So if we align these up, and I zoom in nice and close here, we could see that each of these, so we'd have channel, I can do a line. So that's cool. That's not what I was thinking about. Like, this itself is a channel. This is a channel. Now all the way down. So when I have you, you're a channel. You're a channel. That's its checking here. I guess it's not a channel. The channel is this. I need to be more specific with my verbiage here. So when I'm checking the entities, you're on this channel, you're on this channel, you're on this channel, you're on this channel, you're together in this world, you're not going to interact with each other because nothing is matching. Like the numbers don't line up. So this brings us to fun binary numbers. So the way that binary works is you start in the ones place. Here 2, 3. No, wait. 3. What am I doing? 4, 8, 16, 32, 64, 128. So these are the channels that I have access to in an 8-bit number. Ooh, function deck to bin, return deck 0 to string. Oh, pad start. Oh, there's a pad start. 8. Oh, nice. Wait, you didn't have to pull in left pad? Which is a JavaScript joke for those of us who know. If we're in the know, you know. Let's try it again. So I can do that. Start. I can do 8. had it with zeros. There we go. Here we have with this. So because of this, we see that if we want 8 channels, the numbers, the decimal numbers that we can use are 1, 2, 4, 8, 16, 32, 64, and 128. That's it. Now, if we go to 32 bits, we would have 32 of these digits here, and this number would just like continue to bloom outwards and get really, really, really big. All right, let's continue with this. So basically, you view it as this: if you use a EU32, your game universe consists of 32 layers. Each object has a 32-bit set of flags which denote which layer it exists in, i.e., it exists in multiple layers simultaneously. That's where I did read that before, so that's where this idea came in, where I can put the asteroid and like different bullets. I guess the asteroid would be in 2. And then 1111111 means it exists in all layers at the same time. So yeah, that would be basically, we're just saying, hey, if each one of these is a layer down, we can just say, oh, this specific one, you're in everything, potentially. So a should these objects interact question becomes a simple matter of if layer masks of object 1 and layer mask of object 2 is not equal to 0, then they need to interact with each other. The engine will make sure that objects that exist in the same layers are checked against each other in collision checks. This makes it easy to categorize things that should interact with some objects but not with others. Also, you can add a system which switches layer bitmask on and off after a given amount of time. This has 2 interesting and common use cases. You could, for instance, make bullet missiles become lethal to players after a given amount of time. So that was one of the things I was thinking about. We have a player. Oh, lovely. I still have the arrows on. We have a player, and we're spawning this bullet in the center of the player before firing it off. So then it's like appears here, then it comes here, then it comes here. For example, it probably is actually going to be inside the player for a couple of frames, maybe more than one. And then in that case, we want to make sure it's not doing a collision with the player until it's like out here. And that's what this is. I could basically have everything be in one layer. But temporarily, well, I don't want to move the player into like another one because then the player won't be hit by any of these. So what I would want to do is take that specific bullet and move it into this layer until it like lives for so long, and then it gets put back into here. By using the channels in the opposite way, it can be used to temporarily make objects pass through the player. Think in terms of the player picks up a 3-second power-up, which makes enemies unable to hurt the player. Or, perhaps more commonly, when a player respawns after dying, they need a 3-second period while still being invulnerable to get to a safe location. So something interesting, I put iframes into the Get the Streamer game. The way that I do that is not elegant. I just I check how many ticks that I'm not going to like do the collision detection on, and then it's just a check at the beginning of like, hey, when am I invulnerable? Like, or how many am I invulnerable? True or false? That's a Boolean. And if I'm not invulnerable, then is anything colliding with me? And then when I am invulnerable, I also have like a how many ticks am I invulnerable for, and then it will like flip that flag back on and off. This feels like it would be a little bit simpler of a system, and it would allow me to easily make anything invulnerable as opposed to having to add like that logic to every single creature. Yeah, these layers channels are a generalized method to accomplish these things. So you don't need to write special cases. Yeah, I can see that now. Now I wonder also, is this the same layer system that, or is this like a very similar system that Utsby was talking to us about for the bit map with the ECS? Because I wonder, because I was like sort of trying to think like how would I deal with that? But if it was like this, then it would make a lot more sense. These channels are normally an in-engine thing. So like something would handle this for me. You know, I wonder. That's a good question. Is there any kind of bit mask? How about bit? There's key mods. I'm not. Why are you even grabbing these? Okay. Huh, interesting. Yeah, so I don't think GGEZ has that idea. So I would need to implement this myself, but it sounds like I can just do this and. So if I think of this as we have these channels. I mean, I can also choose like a U8. I could say like we have U8 of channels because I have to do this myself. It like we can make it whatever we want. And so if we know we have channel, I can also do like an enum for each channel, and it would return whatever the channel of this was. So if I want like the first channel, now a big thing is like I'm still wrapping my head and like trying to grok this. So I am thinking in 2 dimensions. I know Epic Blarg, you're talking about like in 3 dimensions, it becomes more of a channel instead of a layer. And it like complicates these things a little bit. I think for right now, I have to stay in the in the 2-dimensional thought until I understand it enough that I can like broaden out. But we can see about how far we can get with this. So given that, now I want to come back into here. Why do I have so many mains in here? What is happening? The layers are a really good mental model, at least for the beginning. Like I might have to come up with, I might have to like throw this mental model out and like come up with another one once I like understand more. But that's what learning is constantly updating our mental model as we get more information. Okay, so given this, I want to like do some, like actually show off some of these things happening. So if I do like a 1 and 2, does that work? Is and a bitwise and? No. Do I have to do a print line? Oh no, okay, here it is. So it does work. So that's a bitwise and. So if that. Now, 3 we learned. A 3 is a 1 and 1 in the right-hand two sides. Now, can I write binary? Can I like actually put in binary? Rust binary. How is that actually like given to the computer? Binary number like set. Okay, so I can do 0B. That's what I could do. So I could also, oh, thank you, Epic Flyer. You also helped me out too. So I could also do this literally. So I could basically have that channel 1, or let's stay with our mental model of layer 1. So we have layer 1 equals 0B. So that's now saying, hey, we're in the binary stuff. And we're gonna do, let's say we do a U8. So 1, 2, 3, 4, 5, 6, 7, 8. And then the first one is that. Oh, and I can then say it's a U32. Interesting. What if I just do that? What do you think that you are? Oh, I thought it would give me the type. I kind of expected it to give me the type there. Does it know that it's a U8? I don't know. If I come, what's Rust Analyzer gonna say? Let's say I just open up one of these random. Let's go to main. Wrong main. I want to go to, no. Playing with hex. Okay. I guess I have more things in here than I thought I did. Okay, so we have this main right here. I just want to experiment around with this. So we're going to do let so layer equals like 0B 1, 2, 3, 4, 5, 6, 7, 8. Here 1, if like that. I32. Okay, so it thinks that it's an I32. Interesting. So then I could change that to be a U32 with that. Or can I even do an U8? I can. So I can do like a U8 and only have like 8 or a U32. It doesn't really matter. I believe I have U32s already in the ECS, so just using a U32 would be easiest. So then I can set like layer 1 is that layer 2 equals 0B is essentially that. Now the problem is that if I want something to be in layer 1 and layer 2, can I add things together? And then otherwise, can I also print out as binary? Let's see. That it feels like I should be able to. Can I? Print binary. Add layers together with or. Oh, okay. So okay, if I want to print binary Rust. Oh, there's a standard format binary. Okay, with B. Okay. So then I can come back to here. So let's do a print line. I want layer 1, and I want you to be a binary layer 1. So if I run you, perhaps that wasn't best. Let's do layer 2. There it is. Okay, so it's again, it's not padding. Was there a padding that I could do with this? I could do L as binary. Oh, okay, no, I can't. But I think that is the hash giving me that? Let's find out. Hash. 0B10. Interesting. Okay, so that doesn't really help me. I know there's like a padding. Can I? Is it something like 8? No, I forget. I forget what the padding is. Zero 8B. Oh, okay. I missed that. Oh, okay. So it padded by spaces. So I want pad with zeros, 8 of them, binary. There you go. There we go. Okay. So cool. We have layer 1 is this. So if I wanted to, let's say we have layer 1 and layer 2 are these things. And then I wanted to do my bullet, which I want to be in layer 1 and layer 2. So if I just like add layer 1 and layer 2, if I just want to make this like very, I don't know, we'll now see like what bullets layers be. I want you to be bullet here. We can now see that it is this. It's in 1-1, which is in both layers, essentially. So now, if I want to determine, should we hit the bullet? So we create a bullet, and it's in both layers. Let's create a player, and this is going to be just in layer 1. Let object 1 layers equals layer 1 or layer 2. Adding works in this case, but as soon as you have collisions, it'll break. Oh, okay. So I want this to be like that, to be more specific. So bullet's going to be in both of these. Player's going to be in just one of them. So we're going to print line bullet, and then we can do another print line. And this will be player and bullet interact. And that's going to be bullet and player. And the answer is yes, because player is on layer 1. Bullet is on layer 1 and on layer 2. And because of that, the player will interact with the bullet. Now, let's say that the bullet is on only layer 2. So if later on I want to remove the bullet from layer 1, so we do this. I want to copy you. I then want to remove bullet from layer 1. How would I do that? So that would be not a, essentially I want to like subtract it, but it's not the pipe symbol. What documentation can I find for this? There must be like a binary stuff. So that's format, but can from here I find more stuff? Not really. That's format, bit maybe? Okay, so, operations. We can maybe find a bit or. So the bitwise OR operator is that. So let's come to here and find the bitwise. Okay, so here's bitwise. We have bitwise and, bit and assign, bit or assign, bit XOR, and bit XOR assign. And is there anything else? No, that's it. What's the XOR? I mean, I've heard people talking about these. I've just never had to I've never been in a position where I had to learn it. This doesn't really explain what it is. Just just says how to do it. But I don't think, I think this is going like beyond what I actually want to do. Okay, so we have this bit or. So you're going to be or this. So I can do an or. Removing means anding with the not of the flag you want to remove. New equals old and not flag. Okay, so let's see how that works here. If I want to now say the bullet is no longer going to be on layer 1. So we're going to do bullet. You probably have to be mutable. Bullet is going to be layer. Bullet is going to be the and not layer 1, like that. Then we're going to see, hey, now do you interact? The bullet layers is now just layer 2, and they do not interact. So what I can do is I can have like the layers written out like this in variables that I can then work with in my brain. So I don't have to work purely when binary. And I can name them. And then I can use this type of math to then add them to layers and remove them from layers. Think you need something different for the bitwise not. So not this. Wait, hold on. I don't think this one has a bitwise not. Let's see if we can search. Bitwise not. Oh, it seems Russ uses bang for bitwise not. Bitwise. If I search for all, I have to search for both together. Guess not. Interesting. Okay. Now down here, I think I saw where I can do like the add with the not. I'm looking for exactly where it like actually has that, like that you can use the bang. Is it just in ops? Oh, trait not. Okay, so I can search for not. And then maybe find the trait not from here. Or maybe, could it be in here too? No. Trait not. Okay, so here's the trait not. It's not. Not helpful. I don't see it implemented for that. Ops. Yeah, that was trait op. That was trait not. I mean, so we know it works. I want to find. Okay, so if I do a bit, let's do bit and. Do we see bit and not applied? No. Okay, we don't. It's an output, self output. And this output could implement not, I guess. That's probably where it is. Let's take a look at your link. That value, okay, so 0FF, that's 1, 1. So that should be 3. Remove the lowest bit, so and not 1. Print line, and then there you go. So we run that, and we should have just 2. Oh, right. Oh, FF, because this expands to everything. So it's 1, 1, 1, 1, 1, 1, 1. Okay. Because it's U with 8. Okay, so everything is in ones here. Oh, I guess like I was thinking of this as binary, but this is hex, isn't it? So whatever that is, that's U8 255 or something like that. Okay, so I think we have a way to get around this. So how can I actually implement this in my ECS? I could have a mask. I don't actually want you in here. Want in our main library here. Let's actually go to names. So we probably want like a bitmask. We can have this be called a collision bitmask. Head back to here and we can register for the world that you have a world collision. Wait. Register collision bitmask to string and unwrap you. So now I can add in a collision bitmask to all of my things. Now, how I want to do that is I want to figure out like the layers. What layer is everything going to be on? And then we can have systems to sort of add them and remove them from each other. Could be really interesting. So what we know we want to do is we want to have everything be on the same layer. So whenever we spawn an entity, so here, create the level text. We don't care about you. You're not gonna even have one at all. Create the score. You're not gonna have one. Lives left. You're not gonna have one. Okay, so nothing happens in here then. So that should be wherever we spawn entity. So we already checked U3. Don't worry about the world. Don't worry about anything in BBECS. Cool. You haven't found anything that does spawn entity. I'm loving how fast this search is. I can just go find it myself faster. Okay, so in helpers, I think we have this like insert asteroid into the world, for example. Okay, so asteroids. And if we think about it, there's asteroids, there's players, and there's bullets. So with our asteroid, we would want to, with component, names, collision bitmask to string, and then the actual data that we're throwing in here. So what does that mean? So it's gonna have to be a U32. Do I have to? Did I like not tell it? I register you. Huh, I don't have to tell it what it is. Interesting. Then I'll just put all the U32s in together, okay? Sort of forgot how my own system works. Okay, so we have the collision bit mask, and then what we're throwing in here is going to be a bunch of U32s, but in like the binary of them. So if we remember that, like you're on layer 1, so I could just say something like you're 1 U32. I could do this, and that would work. But I probably want some system for me to track what this is and like know exactly where you are. So where am I going to put this? Maybe like it could be a bitmask helper, or this might be just something on its own. Like it's not a system. I don't want a manager. But like a bitmask Maybe it is just a helper. Maybe it could be like a struct that I do a bunch of. That's probably a bunch of functions or constants. So I'm thinking if I have an enum of the different layers, and then I have some functions to do with like what layer you're in. Remember that the collision bitmask should mentally be thought of which layer does this object belong to? Or which layers does this object belong to? Yeah. I guess like right now I'm thinking of like what type of functions and helpers do I want in order to like guarantee that I'm applying it the right things and doing the right type of math. So I don't want like a magic number as in 1, because I'm gonna forget that. I want to say like, hey, you're layer 1. Okay, so if you're layer 1, that's just gonna be this 1. And then later on I might want to add you to a different layer, which would like maybe I want you to be in layer 1 and layer 2, which would mean you'd be 3. So I'd have to take this, figure out which layer it is. Oh no, then it would just be doing bitwise and or. I don't have to care about what it is at all. I guess that's the thing is like, I don't care what it is as long as it's set to something. So this might be wrong, but let's go ahead and try creating a new file here. And this can be our bit, we're calling this a bitmap, a bitmask. So if I have like a pub enum bitmask layers, we can have like layer 1 and layer 2. So let's just say I start with those. I have layer 1 and layer 2, and I can have impulse. You can have a layers RS which defines const values. Oh, a const values, yeah. That makes more sense than an enum. So I can have a const bitmask layer 1. You are a let's say you're a U32. You're gonna be equal to make this like really easy for me to remember later on, you're a 0B 1 2 3 4 5 6 7 8. That's what you are. And I can copy you, and you're layer 2. And you're that. And so we can go on and on and on. You can be whatever you want to be. Coming back to our asteroid in here, I want you to just be layer 1, let's say. So that's gonna be bitmask. Of course. Wait. Bitmask layer 1. That's what you are. Oh, I can. Oh, but I can also have like main layer. Instead of just layer 1, I can have you be like main layer. And then this could be a, I don't know what I would want to name like the second layer. Just go ahead and ignore you for a second. So you're going to be main layer. Main layer. That's what you are. Have you found any more yet? We did. Okay, so create the player. So players are going to be with component names collision bitmask to string. And we're going to say that you're on also the main layer. Ship debris doesn't have a layer. Insert asteroid into the world. Okay, so you have a collision bitmask. Bullets. Okay, so this is going to be interesting. Bullets start in like a secondary layer. And then we're going to shift them back into the main layer after a certain number of ticks that they exist. So I wonder if they're like, how would I know when to shift them over? But let's not worry about that right now. So we're gonna have a pub const. I don't know what to call this. This is gonna be like, this is gonna be a different layer that's gonna have like these bullets. So maybe like spawned layer. Safe bullets layer. Okay, let's do it. Safe bullets layer. I like it. You're U32. And you're going to be 0B. Now, what I can do is make you even there. So that'll make it easier to sort of see. That's what you're going to be. Cool. Thank you. So this is a 1. This is a 2. And then the next one will be 4. Because it has to be binary. We have to consider that. Okay, so then we have our safe bullets layer. So we're coming back into here. So with component names collision bitmask. And then you're going to be a safe bullets layer, like that. Now, I need some way to determine when to like put them into the other mask, put them into the other layer. What I can do is maybe have like how long they have lived. So we have this ticks to live, which counts down, but I kind of want like how long they have lived. And then that way I can say, after so much time, we're going to then move you over here. So that would be another register, which means another names. So this is like how long it's lived. Lifespan? Ticks lived? Okay, so we can have ticks lived here. Then we're going to come back into insert our bullet into the world. And we care about how many ticks you've lived. So with component names ticks lived to string, and you're going to be a 0.0 U32. I don't think you're going to live longer than U32. And so then we can have a oh, you might need to be U size. I think ticks to live need, yeah, okay, you need to be U size. It doesn't actually really matter that much. It's just I can now increment you. If you have a ticks to live, increment it. That's it. This can be a very simple system. Okay, so that inserts our bullet into the world, and it's on a safe bullets layer. Display message. We don't care about you. You're just a message. Spawn UFO system. Okay, UFOs need to be on the main layer. Collision bitmask string. The main layer. And I don't care how long you live either. UFO fire bullet. So this creates a new bullet. So we need to do the same thing here. So we're going to do with component names vision bitmask string, and you're going to be on the safe bullet slate. You're going to be in what do we call this? This is the bitmask safe bullets layer. And then we also have to do with component names. This is going to be ticks lived. Okay, so we have your collision bit mask and we have your ticks lived. Okay. We already looked at you. Target dock, don't care about you. So care about anything target. Okay, so that's everything that we care about. Bullets, UFOs, players. Yeah, there's just four things. Bullets, UFOs, and players. That's 3 things, actually. Now, I want to track the ticks lived. So we need a system to update that. So in system, we're going to create a new. This is going to be just increment ticks live system. All right, so we know we're going to take in the world, which is a reference to a world. We're going to turn a result, which is an error result. Okay, so what are we going to do here? We need to query for those ticks lived. So query equals query vector. This should be pretty simple. We're just going to have our names. No, you don't want to know what names are? ticks lived to string you. Lived query get lived to string that. Unwrap you. Okay. So we've got our ticks lived of these. We can now loop through these. So for ticks lived in, I guess like, tick lived and ticks lived. Guess we could just call this ticks. In ticks lived, we need to extract this out. So let ticks data wrapper Okay, so bring in data wrapper, your AU size equals ticks.cast. You're going to be components, cast components. Okay, so it's going to give you. Are you just upset because I forgot to do this? Is that the only reason you're upset not doing this right? Okay, so we have our ticks like that. We want to now mutate that. So we can say dereferenced ticks. We're gonna borrow mutably plus equals to 1. And that's it. That's all we're gonna have to do here. And then we want to increment the ticks lived system. So back to the main library, down to all of you, and want to increment ticks live system, pass in a reference to self.world. All right. So now we're going to see like the ticks lived. And then we want to activate the bullets after a certain number of ticks. So that's going to be another system in here called like activate. Now, this isn't going to be, I guess this would be bullets. So we're going to activate safe bullets system. Fuzz Snob, hello, good morning. What font is that? This font is JetBrains Mono. I just Googled for it, was able to find it and install it. And yeah, it so far is looking pretty good. I do have the, what is it called? I do have like the little special graphics on, so I can get the, get like those things. Which is really nice. Okay, so we're gonna have a pub function activate you. All right, so we're also gonna have a world, reference to a world. We're gonna turn a result, just an error result. Don't forget that this time. Okay, so if we want to activate the safe bullets, I need to determine how many ticks it's been. Ligatures, yes, that's it. Thank you so much. Ligatures. We need to determine how long it's been, how long they've lived. So let query equals world. I didn't pull in world. Okay, so query is gonna be a vector of, and I need two things here. You don't know what that is? Now do you, no, still don't know what that is? Fine. Use, great. Numbers, names. How about now? Names, and I want you to be, we have the ticks lived string. We also have names, and this is going to be the bitmask, the collision bitmask. Okay, so we have ticks lived equal to query.get. Okay, our collision bitmask is equal to a query get collision bitmask. Okay, so we have both those things here, and so we need to like determine how long, you know, until we activate them. So let's just determine. I don't actually know what I want to set that to. Maybe it's going to be something like 5-10 frames. You kind of feel like apologizing for introducing this slight diversion with bitmask layers because the scope was much larger than I anticipated. But this is an extremely reusable system, and I'm certain you'll be able to make use of it in the future. And it fits so well in Asteroids, so you thought it was worth looking into. Also, it's a very ECS friendly concept, which fits into the overall project. I agree. No, one of the big things that I want like for this channel and like for like these videos is I want us all to like learn together. So like the point of this is not for me to like make the game of Asteroid. The point is for us all to learn how to make the game Asteroid better. And so like, yeah, I can make it just a crappy version that just uses all the skills I know right now, or I can improve my skills through Asteroids. So I highly welcome all of these. Now, there is like a little bit of like entertainment type stuff in there. Like if I take too long to learn something, then it's not going to be very fun. And so I might like not do it right then. But I think it was a combination of use suggestiness and also the combination of over here cypherpunk giving out that big long explanation, which like the combination really helped me out and gave me the confidence to be able to do this here in this project. So basically, long way of saying I don't care. I'm happy with it. Now let's see. We have our collision bit mask. Figure all that stuff out. I want to, for each of these, you basically grasp the entire process so you learned it quickly. I blame? No, I give credit to all of you. Like, I don't think I could have done it without all of you helping out. So I'm hoping that anybody who's watching this too is learning this, like getting an idea of it too. And I'm happy to like re-explain over and over again what I know. And that's actually kind of the secret of how I learn quickly is I then re-explain it out into the Twitch stream. It's sort of like teaching, which is the fastest way to learn. It's a way to cheat in learning. Okay, so collision bit mask. I want to loop through all of these. And so we know, like we can have a guard here. Like this should never not be exact, not equal. So we can have like assert equal that like ticks lived. Let's just do an assert. That like our ticks lived dot length should be equal to the collision bit mask dot length. And like go ahead and just crash if it's not, but that should never happen. So the thing I learned recently is that this is like a common thing to see in like more senior level code is these type of guards where you're like, well, this should never ever happen. Therefore, let me know when it happens because the impossible happens quite often. And those are the hardest bugs to fix, is because we assume that they can never happen. Okay, so we have a query here for each of these. We're going to go for index, and we can just say like ticks. It doesn't matter which one we're doing. Okay, so for index and ticks in our ticks lived iter enumerate, that gives us this. We can cast down the ticks. So ticks, this is read only, so we don't really care about it. You're a data wrapper. You're a data wrapper with a usize equal to ticks. I don't know why suddenly Rust Analyzer is not pulling in all these things anymore. It used to, and it's not doing that. So we're gonna cast you there. So that gives us that. Now we have access to the ticks. And we probably want to do the exact same thing to the collision bit mask. So let's rename you to masks. Collision bit mask. It's going to be a data wrapper. And you're going to be a U32. And you're equal to a collision bit mass of index cast you. Okay, then I want to, we're going to activate the safe bullets. So I want to, if you're over a certain age, so if ticks borrow. Okay, so if you're greater than, let's say, I don't know, 10 frames. If you live for 10 frames, then we're going to now say dereferenced collision bit mask. We're gonna have to borrow you mutably. I want to plus equals you. No, that's not how to do it. It's plus or you. Is that what I did? Oh, it's and equals. That's what I want. And equals. It's not really and. It's a bitwise and. U2. Oh, and actually, you know what? I'm just setting you to. I don't need that. I just need to set you to the main layer. If you knew what that was. You can reassign. Yeah. I was thinking that like I wanted maybe in multiple layers, but no, I just want to reassign you. You're now in the main layer. There you go. So if you're over 10, now what I could also do is I could just say, hey, if you're equal to 10 now, which means I can do this here, and we're only gonna do like the rest of the calculations if we're 10. Then mask. Okay, so we're that. We then assign you to the main layer, and that should be it. Now you're in the main layer. So now we're going to activate the safe bullets. So back to the main library. Activate safe bullet system. Pass in the world. and unwrap you. So I hate to do this, but it is 8:25 and it's my sprint day today. So and like the person I normally work with in order to like prepare for the sprint, he's now in an executive meeting all morning before all day sprint meetings. So lovely for him. But it also means that I'm on my own for the sprint planning for my team. So I do need to go off and do that. So I'm so sorry that I can't actually finish implementing the collision detection parts. We did the bitwise parts. I need to save this for next time. Now, next time is going to be on Sunday, and I'm going to do a longer stream. So we should have the entire collision system all up and working on Sunday morning sometime. I usually start around between like 8:30 and 9, 8:30 to 9:30 or so. It's going to be really interesting getting this all set up and going. And now I have this handle bullets hitting chips. That's where we're going to do the magic for it. It's going to happen in here. So use bitmask for the collisions. So it's gonna be a lot of fun. Anyways, I'm gonna go ahead and mark down what we did today. So this is day 28. And what are we doing? We are setting up bitmask for collisions. And I'll go ahead and push that up. And I'm now going to go ahead and end the YouTube video. So I'll see you in the next one.